Hi viewers, today we are going to talk about machine learning and algorithms. Before we start, we want to help you understand some difficult words and abbreviations related to these topics. Our main aim to assist those who are interested in AI but might find these technical words confusing. We want to make it easier for you to learn about these concepts. In simple words, machine learning is a way computers learn from data to improve their performance on a specific task. Algorithms are sets of instructions that help computers solve problems or perform tasks. Our goal is to explain these ideas clearly. So, if you are interested in AI, stick around, watch our video, give it a thumbs up, and subscribe to our channel. If you have any questions, feel free to ask in the comments section below. Thank you for joining us. Introduction to machine learning algorithms. Machine learning algorithms are like special tools that help computers learn from information. They are used to turn data into useful models. The choice of which algorithm to use depends on the problem at hand, the resources available, and the type of data being dealt with. How machine learning works. Unlike regular computer programs, machine learning algorithms create models without fixed rules. They can handle different types of data in various ways. Types of machine learning algorithms. Regression predicts numbers like forecasting income. Classification sorts things into categories, such as predicting if a loan will be paid back. Supervised learning uses labeled data with answers for training. Unsupervised learning finds pattern without labeled data. Data encoding and normalization. To make sense of data, we often turn test labels into numbers and ensure that all data is on a level playing field using methods like normalization. Features are measurable aspects of what we are studying. Feature vectors are numerical representations of these features. We have to be smart about choosing which features to use and how to handle them to make accurate predictions. Common machine learning algorithms. There are many different algorithms, each suited for specific tasks. Linear regression is like drawing a straight line through a bunch of points on graph. Imagine you have some dots on a piece of paper and you want to find the best fitting straight line that goes through these dots. Linear regression helps us find the line. In the real world, we use linear regression to predict things. For example, if we know the numbers of hours someone studies and their test scores, linear regression can help us predict what their score might be if they study more or less. So, it's like figuring out a simple pattern in the data, drawing a line based on the pattern, and then using that line to make predictions. That's what linear regression does. Logistic regression is like teaching a magical box to predict outcomes such as whether it will rain or not based on factors like temperature and humidity. Unlike simple yes or no predictions, logistic regression gives us probabilities, indicating the likelihood of an event happening. It works by analyzing different factors and understanding their relationship with the outcome, helping us make more nuanced predictions. Think of it as having a weather wizard that can estimate the chances of rain using various clues, making it useful when situations are more complex than straightforward answers. Decision trees. Imagine you have to make a series of decisions, like whether to play outside or stay indoors. Decision trees in AI work a lot like that. They are a way for computers to make decisions by following a tree-like structure. At the beginning of the tree, the trunk, there is a big question, like, is it raining? Based on the answer, the tree branches out into more questions, like, do you like playing in the rain? Each question leads to more questions until you reach an endpoint, like stay indoors and read a book. Decision trees. In AI, decision trees are used to solve problems step by step. For example, in healthcare, a decision tree could help doctors diagnose diseases. If a patient has symptoms like fever and cough, the tree might ask, is there difficulty breathing? Depending on the answer, it guides the doctor towards possible illness. Decision trees are like smart flowcharts, helping computers make choices just like you do, but by following logical path of questions and answers. They are powerful tools used in various fields to make decisions based on data and are easy to understand, even for high school students. Support vector machines. Support vector machines SVM in AI are like superheroes that help computers classify things. Imagine you have a bunch of different objects like apples and oranges and you want the computer to figure out which is which. SVM is a smart algorithm that draws a line, or in more complex cases, a plane or a curved boundary between these objects in a way that maximizes the gap between them. Picture a game of catch where you have to separate two teams of players using a rope. The best way to position the rope is where it's equidistant from players on both sides. SVM works in a similar way. It finds the best liner or boundary that separates different types of data while keeping the widest possible space between them. SVM is incredibly useful because it not only helps in distinguishing between apples and oranges, but also in more complex tasks like detecting spam emails, predicting diseases, or recognizing handwritten letters. It's like drawing the most efficient line between what's right and what's wrong in a sea of data, making it a superhero in the world of artificial intelligence, helping computers make accurate decisions. AutoML system. These tools automate the process of choosing the right algorithm and preparing the data. Feature engineering. Creating new features or simplifying existing ones. Hypermeter tuning. Tweaking the models to make them work as best as they can. So viewers, today what we have learned so far, now we will see what is the conclusion. Machine learning algorithms are crucial, but they are not the whole story. Successful machine learning also involves picking the right features, cleaning up the data, and sometimes using automated tools to help out. Understanding all these parts is the key to making machine learning really work in the real world.